Yes. Good afternoon, students. In last class we have discussed some problems on the concept of vector product, right? So let us continue remaining problems, that is exercise problems. Exercise 10.4. You know that vector product of two non-zero vectors is given by A vector plus B vector, that is equal to magnitude of vector A, magnitude of vector B into sine of the angle and n cap. N cap is the unit vector which is perpendicular to both the vector A and the vector B, right? And theta is the angle between the vectors A and B. Now let us continue the problems based on this concept. Next problem, exercise 10.4, first problem. So find magnitude of vector A cross vector B. Find magnitude of vector A cross vector B. If vector A equals I minus 7j plus 7k, I minus 7j plus 7k, and vector B equals 3i minus 2j plus 2k, and vector B equals 3i minus 2j plus 2k. So find the magnitude of vector A cross vector B. If A vector equals I minus 7j plus 7k and B vector equals 3i minus 2j plus 2k. So here we have to find just length of vector A cross vector B. Magnitude means you know that is the length of the vector A cross vector B. So to find the magnitude of vector A cross vector B, first we just have to find vector A cross vector B. What is the vector? You know that vector product of two non-zero vectors is again a vector. Now we are going to find the vector A vector plus B vector. So we have here it is given that vector A is I minus 7j plus 7k, and vector B is 3i minus 2j plus 2k. Now vector A cross vector B is given by a first row elements, determinant of first row elements I j k. So next row, second row elements, coefficients of I j k in vector A. Third row element, coefficients of I j k in vector A, right? You know that. Now coefficient of I is 1, coefficient of j is minus 7, and coefficients of k is 7. Like that, similarly, coefficients of I j k in vector B is 3 minus 2 plus 3. Now expansion of the determinant along first row. It will be the expansion along first row. So it will be A vector plus B vector. That is equal to, see, first row first element, determinant sign plus into element is I is there, deleting first row first column. Treatment becomes minus 7 plus 7, minus 2 plus 2. Again, first row second element, determinant sign becomes minus, element is j cap, deleting first row second column. Treatment becomes 1 7 3 2. Again, first row third element, determinant sign becomes plus and element is k is there, deleting first row third column. Treatment is 1 minus 7 3 minus 2. 1 minus 7 3 minus 2. Okay. Now simplify this. It will be vector A becomes A vector cross B becomes, see, I cap into unit vector I into say minus 7 into 2 minus 14 minus of again minus 2 into minus 2 into 7 that becomes minus 14 minus of minus becomes plus 14 I cap into minus 14 plus 14 so minus j cap next unit so 1 into 2 minus 3 into 7 20 plus k again this element becomes 1 into minus 2 so minus of 3 into minus 7 minus 21 minus 2 is minus of minus becomes plus 21 now vector a cross b that becomes I of minus 40 plus 40 that is 0 0 into I cap minus j unit vector j into 2 minus 21 that is minus 19 minus of minus becomes plus 19 unit vector j right here minus 2 plus 19 plus 19 into unit vector j. Next we have to find a vector after this we next we have to find magnitude of vector a cross vector you know the magnitude of vector a cross vector b is given by root of x square components x square plus y square plus z square x square means here 0 square becomes 0 plus 19 square plus 19 square and 19 square plus 19 square that becomes 2 times of 19 square right 2 times of 19 square apply square to each term 2 and 19 we will get square root 2 and square root of 19 square a square root cancel that is 19 times of root 2 what is this magnitude of vector a plus vector a so required magnitude of a vector plus b vector is 90 times of root the distance of a vector plus b vector magnitude of a vector plus b vector becomes 90 times of root that's it okay like this next problem exercise 10.4 next problem so finally a unit vector so find a unit vector so find a unit vector perpendicular to each of the vector perpendicular to each of the vector a vector plus b vector and a vector minus b vector. Find a unit vector perpendicular to each of the vector a vector plus b vector, a vector minus b vector, where vector a is equal to 3i plus 2j plus 2k. Where vector a is equal to 3i plus 2j plus 2. Vector b is equal to I plus 2j minus 2k. I plus 2j minus 2k. I plus 2j minus 2k. So find unit vector perpendicular to each of the vector a vector plus b vector and a vector minus b vector, where vector a is 3i plus 2j plus 2k and vector b is I plus 2j minus 2k. I plus 2j minus 2k. So first here we have to find. We just have to find a vector plus b vector and a vector minus b vector. Next we have to find a unit vector which is perpendicular to both vectors. See, in a vector product, you know that vector product of two non-zero vectors is A vector plus B vector, that is equal to magnitude of vector A to magnitude of vector B sine of the angle and unit vector. We just have to find this one, right? So in terms of these two vectors, see, to find this one, here angle is 90 degree because it is perpendicular to both the vector, right? This unit vector is given by A vector product upon magnitude of the vector into magnitude of A sine pi by 2 is 1, that is equal to unit vector. Using this concept, we are going to solve this problem, right? See, now we have to find the unit vector in terms of the given vectors A and B. That is, here vector A means vector A plus B, vector B means vector A minus B. So now I am going to find A plus B vector and A minus B vector first. So first we have to consider the vectors. Vector A is given, vector A is 3i plus 2j plus 2k, and vector B is I plus 2z minus 2. Now find out additional thing, sum of the vectors. Now sum of the vectors means A vector plus B vector, that becomes, that is equal to, see, A vector plus B vector, 3 plus 1 into I, that is 4 into unit vector I, plus again 2 plus 2 is 4 into unit vector j, plus 2 minus 2, that becomes 0 into unit vector k, that is A plus B. Similarly, A vector minus B vector, that is equal to A vector minus B vector, that is equal to A minus B means 3 minus 1, 2 into unit vector I. Again 2 minus 2, that becomes 0 into unit vector j, and 2 minus of minus 2, 2 minus of minus 2 becomes 2 plus 4, 4 into unit vector k. Now let I call A vector plus B vector means vector P. P vector means sum of the vector A vector plus B vector, and vector Q means difference of the vector A minus vector A. Now next find out vector, that is now P vector cross Q vector. It is given by P vector means sum of the vector A plus vector A. Q vector means difference of the vector A vector minus B vector.